Welcome to everyone. I am Dr.S.Kanchana, Assistant Professor, Department of Physics, Sita Lakshmi Ramaswamy College, Trichy. Here I am going to explain about the experimental investigation of a Raman spectroscopy. Before going to the Raman experiment, we see a small introduction about Raman effect. Scattering of a light refers to the phenomenon in which light interacts with the matter and changes its direction or deviate from their original path. This deviation or a scattering can happen in a various ways depending upon the size of the particles or structures relative to the wavelength of the incident light. Rayleigh and Raman scattering are two fundamental phenomena related to the interaction of a light with matter, each providing a unique information about the properties of the scattering material. Experimental study of a Raman effect. In this figure, AB is a glass tube containing a pure liquid. The liquid is free from dust and air bubbles. The tube is closed at one end by an optically plain glass plate W and the other end by an blackened horn. That is, no light can be entered or passed away. Light from the mercury arc S is passed through the filter F. This filter allows only a monochromatic radiation of a wavelength lambda equal to 4358 degree Armstrong. The tube is surrounded by a water jacket J so that the water is circulated to prevent the overheating of the liquid. A semi-cylindrical aluminum reflector R is used to increase the intensity of the illumination. Scattered light is perpendicular to that of the incident light which passes through the slit and convex lens. The spectral lines are observed with a high resolving spectrometer, a detector such as a charge coupled device, camera, or a photomultiplier tube captures the dispersed spectrum of a scattered light. The detector records the intensity of the light at each wavelength. It is observed that the spectral lines contains original wavelength at 4358 degree Armstrong. In addition to that original wavelength, some lines having a longer as well as a shorter wavelengths. These modified wavelengths are called as Raman lines. The lines having a wavelength greater than that of the incident wavelength is called Stokes lines, and those having a shorter wavelength are called anti-Stokes lines. The Stokes lines are found to be more intense than that of the anti-Stokes lines. Most of the Raman lines are strongly polarized. The Raman spectrum provides information about the sample's molecular composition, structural properties, and chemical bonds. In the spectrum, the peaks corresponding to specific vibrational modes, allowing for a compound identification and characterization. Raman spectroscopy is a versatile technique used in various scientific fields, including chemistry, material science, biology, and pharmaceuticals. It provides valuable information about molecular vibrations, making it a powerful tool for a chemical analysis and research. Thank you.